Greetings and welcome to Physical Science at Hack. In this video, we're going to work through the sample problems for Chapter 11 on water and solutions. So let's go ahead and get started. Our first problem asks or tells us that a 50-gram sample of a saline solution contains 1.75 grams of NaCl, sodium chloride. And we want to know what is the percentage by weight concentration. Well, let's start off with looking at what equation we would want to use. And we know that the equation we can use is the percent solute is equal to the mass of the solute divided by the mass of the solution times 100% of solution. So what do we know? Let's write down our known. We know the mass of the solute is equal to 1.75 grams of sodium chloride. We know that the mass of the solution is equal to 50.0 grams. And we want to find the percent weight. So that's what we're going to be looking for. So we know essentially everything to go into this equation, and all we want to find is the percent of the solute here. So let's go ahead and put those numbers in, and we find that the percent solute is equal to the mass of the solute, which is 1.75 grams of sodium chloride, 1.75 grams sodium chloride, divided by the mass of the solution, which was 50.0 grams of the solution, times 100% solution. Now the solutions cancel, and we're just going to be left with some number, some percentage of sodium chloride. So if we multiply these, take 1.75, divide it by 50, and then multiply it by 100, we find out that we would have 3.75% NaCl for our answer. So we just had to use the equation directly here, and that gives us our answer of 3.75% sodium chloride. So that is our first problem, and we'll see that our next couple will really use very similar equations. So our next question says that seawater contains 30,113 parts per million by weight dissolved sodium and chlorine ions. And we want to find the percent concentration of those. So we want to find the percent concentration of sodium chloride in water. Well, a percent is equal to the part divided by the whole. So percent is equal to the part divided by the whole. Or in this case, it is equal to the part, which is 30,113 grams of sodium chloride ions, divided by 1 million grams of seawater. Times 100% times 100% seawater. So in this case, we're just looking, what we mean by parts per million is how many out of each million, and that's just dividing. So just like a percent is out of 100, a part per million means that we have this many grams of sodium and chlorine atoms per million grams of seawater. And when we divide those two, so we divide 30,000 by 1 million and then multiply it by 100, our seawaters cancel over here. And we're going to have the grams canceling, and that's simply going to give us 3.00% sodium chloride ions. So we just need to divide those there. That gives us our answer of 3% sodium chloride ions. Now our third question, let's look at our third question here, asks what is the mass of hydrogen peroxide, which is H2O2, in 250 grams of a 3% by weight solution. So again, we're going to be using the same equation we used in the first question there, which was that the percent of the solute is equal to the mass of the solute divided by the mass of the solution, times 100% solution. So let's look at what we know. In this equation, we know the mass of the solution is given to us. And that is 250 grams. So that's right here. We also know the percent of the solute. That's given right here. That's 3.0%. So we know those two things. So we know the percent of the solute here. We know the mass of the solution. We can then solve for the mass of the solute. So we can solve this equation and say that the mass of the solute is equal to the percent of the solute times the mass of the solution divided by 100% solution. So now we know everything on the right hand side. We can put those numbers in and get that the percent of the solute was 3.0%. We multiply that by the mass of the solution, which was 250 grams. And we divide it by 100% solution. And if we multiply those out and divide by 100, we're going to find that it is 7.5 grams of hydrogen peroxide, H2O2. So that gives us our answer for this. What is the mass? Well, it's 7.5 grams of hydrogen peroxide in that solution. All right, move on to number 4 here. Number 4 asks how many milliliters of pure alcohol are in a single cocktail made with 50 milliliters of 40% vodka. So we're going to use our same equation that we've been using here, that said that the percent of the solute is equal to, in this case we're looking at volume, so volume of the solute divided by the volume of the solution times 100% solution. So we have to look at what we know here. And what we know is the percent of the solution is 40%. And note there, if you're ever comparing when it says proof on an alcohol, proof is actually twice the percentage. So this would be an 80 proof vodka, which is 40% alcohol by volume. So we know that. We know the volume of the solution which is 50 milliliters. And we want to find the volume of the solute. That is what is unknown. So we're going to be looking for the volume of the solute. So we're going to have to rearrange our equation here again to solve for the volume of the solute and find that the volume of the solute is equal to the volume of the solution times the percent of the solute divided by 100% solution. So now we know everything again on the right hand side. We can put those numbers in. The volume of the solution is 50 milliliters. We know the percent of the solute. We're going to multiply that by is 40%. And we're going to divide that by 100% solution. So when we multiply those out, we are going to find out that that gives us 24 milliliters of alcohol. So our answer for that would be 24 milliliters of alcohol there, based on the numbers that are given. All right, we have one more here. Let's look at our last problem to look at. And that says that fish in a certain lake are reported to contain 5 parts per million by weight DDT. So we have a two-part question here. First part says what percentage of the fish meat is DDT? So let's look at that first of all. A percent concentration is equal to, let's write that down, percent concentration is equal to the parts per million divided by 10,000. So we take the number of parts per million, divide that by 10,000. That will give us the percentage concentration. Essentially, we're taking it from parts per million and converting that to a percentage. And that's why normally if you do parts per million, you do 5 out of a million. Here we want to get it to a percentage. So instead of doing it out of a million, we're doing it out of 10,000. There's a factor of 100 missing there. So this would be the parts per million is 5.0. We divide that by 10,000 and get the answer. This is part A here, and get the answer of 0.00050% DDT. So that is our answer for part A, the percentage of DDT in the fish meat. Now part B, we want to know how much of this fish would need to be consumed to get 17 grams. So we're trying to see how much the whole would have to be to get 17 grams of DDT. So for this, we're going to use the equation that the percent of the part, the DDT that we're looking for, is equal to the part divided by the whole times 100%. So the percent of the part, and we're going to then put our numbers that we know in here. What do we know? Let's write down the numbers that we know. We know that there are, we know that the percentage is we've just figured out the percentage of DDT is equal to, let's put this in here. The percentage of DDT is equal to 0.00050%. And we know that the mass we're looking for, the mass of DDT, or the part that we're looking for, so the part is equal to 17 grams of DDT. And we're going to be looking for the whole. The whole is what we're looking for. How much fish needs to be consumed to get this part, to get those 17 grams of DDT. So we know what the part is. We want to figure out what it is. That is the poisoning amount of DDT, and we want to know how much we have to consume to be able to get that. So we're going to have to rewrite this equation so that we can find the whole. So the whole is equal to 100% times the part. So it's the part times 100% divided by the percentage of the part. We know all of those numbers now. The percentage of the part is the percentage of DDT. So we can put our numbers in. The part is 17 grams. We know 100%. And we divide that by the percentage of the part, which is 0.00050%. And that means how much fish needs to be eaten is, once we calculate that, 3,400,000 grams. So let's put that in here, 3,400,000 grams, or 3,400 kilograms of fish. So that is how much fish would need to be consumed. It doesn't give you a requirement for either of these to be answered in grams or kilograms. So either one of these would be fine, but that would give you the amount of fish that would need to be consumed in order to get this 17 grams of the DDT that is made up that is part of the fish. So that concludes our working through the sample problems for chapter 11, and we'll be back again next time to work through some sample problems for chapter 12 in the textbook, which is on organic chemistry. So until then, have a great day, everyone, and I will see you in class.